discuss some numericals relating diffraction. First question, a parallel beam of light of wavelength 600 nanometer is incident normally on a slit of width A. If the distance between slit and the screen is 0.8 meter and the distance of second order maximum from the center of the screen is 15 millimeter, calculate the width of the slit. So, what are given here? Wavelength is 600 nanometer, lambda is equal to 600 nanometer, 600 into 10 raised to minus 9 meter. We have to find out the width of the slit. Width of the slit is represented by A, that is equal to question mark. The distance between slit and the screen, that is represented by capital D, 0.8 meter. The distance of second order maximum from the center. We know that in diffraction pattern at the center maximum or bright fringe is formed. So, the distance between the position of maxima, secondary maxima from the center is, we can write y. So, the condition for, we know the condition for maxima is, what is the condition for maxima? 2n plus 1 into lambda by 2, path difference is equal to 2n plus 1 into lambda divided by 2. This is the condition for maxima. Okay children, so the position of maxima from the center is given by y equals 2n plus 1 into d lambda divided by 2a. So, we know position of maxima from the center is given by y equals 2n plus 1 into d lambda by 2a. In the case of interference, the position of minima is y equal to 2n plus 1 into d lambda by 2d there. But here in the diffraction condition, diffraction pattern, position of maxima is y equal to 2n plus 1 into d lambda by 2a. This is the formula. And y is given by, what is the position given here in the question? It is given by the position of second order maxima is 15 millimeter. So, 15 millimeter. Second order maxima means we have to put n equal to 2, because in diffraction second order means n equal to 2, third order means n equal to 3, no change. So, here put n equal to 2 and y equal to 15 millimeter, that is 15 into 10 raised to minus 3 meter. Clear children? We can use the value, use the formula 2n plus 1 into d lambda by 2a equal to 15 into 10 raised to minus 3. So, n equal to 2, so that is 5 d lambda by 2a equal to 15 into 10 raised to minus 3. We can substitute 5 into what is capital D, 0.8. What is lambda? 600 into 10 raised to minus 9 divided by 2a, we have to find out, is equal to 15 into 10 raised to minus 3. So, after simplification, a is equal to 8 into 10 raised to minus 5 meter. So, slit width is given by 8 into 10 raised to minus 5 meter. Now, second question, a screen is placed 2 meter away from a single narrow slit. Calculate the slit width if the first minimum lies 5 millimeter on either side of the central maximum. Incident plane waves have wavelength 5000 angstrom. Now, what are given here? The screen is placed 2 meter, that means capital D equal to 2 meter. Calculate the slit width, A equal to question mark. Then wavelength is also given, that is 5000 angstrom, 5000 into 10 raised to minus 10 meter. Then first minima lies at 5 millimeter from the central maximum. First minima. What is the position of the minima? Position of minima is y equals, what is the formula for minima? D and lambda by A. In the case of interference, the position of maxima is d and lambda by d. But in the case of diffraction, position of minima is y equal to d and lambda by A here. Okay, here the position of first minima means n equal to 1, first minima n equal to 1. Clear? So, y is given as 5 millimeter. So, n is equal to 1, y equals 5 millimeter means 5 into 10 raised to minus 3 meter. So, all the values are given. We can directly substitute. So, 5 into 10 raised to minus 3 equal to capital D, that is 2 meter, into n, which is 1, into lambda 5000 into 10 raised to minus 10 divided by A is equal to A equals 2 into 1 into 5000 into 10 raised to minus 10 divided by 5 into 10 raised to minus 3, and the answer is 2 into 10 raised to minus 4 meter. So, slit width is 2 into 10 raised to minus 4 meter. Now, move on to third question. Light of wavelength 550 nanometer is incident as parallel beam on a slit of width 0.1 millimeter. Find the angular width and linear width of the principal maxima in the diffraction pattern on a screen kept at a distance of 1.1 meter from the slit. Which of these widths would not change if the screen were moved to a distance of 2.2 meter from the slit? So, what are the values given? Wavelength is 550 nanometer. So, it is 550 into 10 raised to minus 9 meter. Slit of width 0.1 meter. Slit width is represented by A. It is 0.1 millimeter. You can convert to meter. We have to find out the angular width and linear width of the principal maxima. What is the angular width of the principal maxima? Means the central maximum. Angular width of the central maximum, we know it is theta is equal to 2 lambda by A, that is angular width. What is the linear width of the central maxima? 2d lambda by A. Okay, so angular width is 2 lambda by A and linear width is 2d lambda by A. So, we have angular width for the central maxima. Angular width is theta is equal to 2 lambda divided by A is equal to 2 into, we can substitute lambda, 550 into 10 raised to minus 9 divided by 0.1 into 10 raised to minus 3. It is equal to, so answer is 1.1 into 10 raised to minus 2, since it is angle radians. Okay, now we have to find out the linear width. Linear width is beta. Beta is equal to 2d lambda by A. Okay, 2d lambda by A. So, it is equal to 2 lambda by A is this one, no? So, 1.1 into 10 raised to minus 2 into D. What is D here? Capital D is equal to 1.1 meter. So, 1.1. So, the answer is 12.1 into 10 raised to minus 3 meter. Now, which of these width would not change if the screen were moved to a distance of 2.2 meter from the slit? If screen is moved means capital D increases to 2.2. Okay, capital D changes to 2.2. Which of these width would not change? So, angular width would not change. No, angular width does not depends on capital D. So, angular width would not change, but what happens to linear width? It will change. So, answer angular width would not change because it is independent of capital D. Now, next question. The slit of width A is illuminated by light of wavelength 5000 angstrom. For what value of A will the first maximum fall at angle of diffraction 30 degree? So, here the question, for what value of A? So, A represents the slit width, that is equal to question mark. Lambda is given 5000 angstrom, 5000 into 10 raised to minus 10 meter. Now, theta is the angle of diffraction. Okay, angle of diffraction theta is equal to 30 degree. For what value of A will the first maximum fall at angle of diffraction? So, what is the position of the maxima? The position of the maxima is path difference is A theta is 2n plus 1 into lambda by 2. So, this is the position of maxima. This is the condition for maxima. Here we have to find out A. Theta is known. What is theta? 30 degree. But here usually we have taken approximation sin theta is approximately equal to theta if angle is very small. Since the angle is given, you can write A sin theta equals 2n plus 1 into lambda by 2. Since the value of theta is known. Okay, so no need to substitute theta is equal to 30 degree, we have to take the sin value. So original formula is A sin theta is equal to 2n plus 1 into lambda by 2. That is the condition for secondary maxima. So the condition for secondary maxima is A theta is equal to 2n plus 1 into lambda by 2. This is the approximate value. The original form is A sin theta because we had derived the formula for path difference as A sin theta. Since the angle is given in degree, we have to take the sin theta. Okay, A sin theta. So we can write A sin theta is 2n plus 1 into lambda by 2. Now we have to find out A. So we can substitute A into sin 30 degree equal to 2 into what is the value of n here? N is equal to first maxima, no? So n equal to 1. So 2 into 1 plus 1 into lambda divided by 2. Now we can simplify. So A equal to, simplify A into sin 30 is 1 by 2 is equal to 3 lambda by 2. Then A equal to 3 lambda, that is 15 into 10 raised to minus 7 meter. Okay. Fifth question. A screen is placed 50 centimeter from a single slit which is illuminated with light of wavelength 6000 angstrom. If the distance between the first and the third minima in the diffraction pattern is 3 millimeter, find the width of the slit. Screen is placed 50 centimeter from the single slit. The position of the screen is represented by D. D equal to 50 centimeter. We can convert to meter. 50 into 10 raised to minus 2 meter. Okay. Now wavelength is also given. Wavelength is 6000 angstrom into 10 raised to minus 10 meter. Okay. The distance between the first and the third minima of the diffraction pattern. What is the position of the first minima? Position of the first minima. Position of first minima. We have the position of the minima. What is the position of minima? What is y equal to dn lambda divided by a. That is the maxima in the interference pattern. Okay, so here minima. The position of the minima is dn lambda by a. Position of the first minima means n equal to 1. So it is equal to d lambda by a. Okay, what is the position of the third minima? We can write y3. Position of the third minima is y3. We can put y3. That is equal to 3d lambda by a because put n equal to 3. Position of third minima means n equal to 3d lambda by a. Okay, so here the question is the distance between the first and the third minima is 3 millimeter. That means y3 minus y1 is 3 millimeter. So y3 minus y1, that is 3d lambda by a minus d lambda by a, that is given as 3 millimeter in the question. Okay, so 3d lambda by a minus d lambda by a means 2d lambda by a, that is equal to 3 into 10 raised to minus 3. All the values are given. Capital D is known, lambda is known. We can find out a. After simplification, the answer is 0.2 into 10 raised to minus 3 meter, that is 0.2 millimeter. Okay children.